In this video, we're going to continue with solution of triangles, and we're going to start off with the cosine rule. So just like we did with the sine rule in the previous video, whenever we're dealing with a triangle that isn't right angled, we can't use normal trig, and so we have to apply slightly different rules. The rule that comes along when using the sine rule is something like this. So if we've got a triangle and we label the sides A, B, and C, we also then know that the opposite sides are the lowercase letters. So in other words, if this is the angle A over there, if we go and have a look at the opposite side, that will be the lowercase letter A. And then this will be the lowercase c and the lowercase b. Now what you're going to see when we're dealing with the sine rule is the main condition is that we will always have one angle, which can be that angle A over there as an example, and then two sides that include that angle. So we're basically saying it's two sides and an included angle. Now what I mean by an included angle in a triangle is that we've got the two sides and then we've got the angle that sits between those two sides. So always make sure that the angle sits between two given sides. That's basically what we're looking for. And when we go and apply the formula, it will be to work out the side or the length of the side that is opposite that angle. So in other words, that side there that I highlighted in green. So just like with the sine rule, when we write out the formula, we always start off with what we're looking for. So we start off, we're looking for A. So it's going to be A squared is equal to. And then we go to those two included sides, or those two sides, B and C. So basically, you take the side that you're looking for on the one side of the formula, and then on the rest of the formula, on the right-hand side, it's only going to be those other two sides. So it's going to be A squared is B squared plus C squared minus 2. And then you just repeat the two sides that you've just written before. So we've got B and C, so it's going to be 2B times C times cos of the included angle. So in this case, it's cos of angle A. So that's the cosine rule. It's the side we're looking for, and then we move on with the two sides that are adjacent or next to that included angle, and then obviously the included angle itself. And now what I've gone and done here as well is I've added in a second block because I know sometimes people find it difficult to get this cos by itself. So basically you can think of it that this first formula over here, that's for when we're looking for the length of a side. Whereas if we want to find the size of an angle, we're going to have to rearrange this formula slightly and make cos of A the subject. And the way that you can do that is we will get cos of A is equal to B squared plus C squared minus A squared over 2BC. So it's just me rearranging the formula to make cos A the subject so that I could find the angle if that's what the question's asking. And remember, if you've got to find the angle, you need to use that inverse cos operation on your calculator. So you're going to put shift and then cos. So those are the two formulas that we've got for the cos rule. I hope you understand that it's the included angle and the two sides that are next to it that form this entire right-hand side of the formula. And on this side of the formula, it's simply the side that's opposite to that included angle for the left-hand side. The two conditions that we have for using the cos rule are firstly, two sides and an included angle. So in other words, you need to have two sides and an included angle to use that rule. Or alternatively, you need to be given the lengths of all three sides in that triangle. So those are the two conditions that we have for the cos rule. Make sure you learn them as well as you can. So let's start off then by having a look at how to solve a question when dealing with the cos rule. So in the triangle below, we could have it stated as triangle ABC. And the question says to us, determine the length of the side AC. So in other words, they want us to find this length over there that I've highlighted in yellow. And so you need to ask yourself the question, what information am I given in this triangle? Well, I'm given the lengths of two sides, and I'm also given the size of an included angle that sits between those two sides. And so the condition to use the cos rule is fulfilled. And so now we've got to go and write out the formula. And as I said before, we're going to break that formula up into a left-hand side and a right-hand side. On the left-hand side, that's basically what you're looking for. That's what we want to figure out. So in this case, it's going to be AC squared. And on the right-hand side, that's the information that you're given. And the information that you're given is obviously the two sides and the included angle. So the two sides that we are given, and I'm going to start off by writing it out using symbols. Obviously in an exam, you could just go straight to the substitution. But it would be CB squared, which is this side over here, CB squared, plus the other side that's next to that included angle, which is going to be AB squared. So this side over there, AB squared, minus 2. And as I said before, the part that comes after that 2 is simply the two sides that you wrote just before it. So it's going to be 2 times CB times AB times cos of the included angle, which in this case the angle is angle B. So we can write it as cos of angle B. So now we've gone and written out our formula, we can then go to our substitution. So the side CB, that's 16 centimeters, plus AB, which is 18 centimeters, minus 2 times 16 times 18 times cos of 32 degrees. Now obviously we want to find the length of AC, not AC squared as it's given. And so the way that we can do that is to simply write it as AC and then square root that entire right-hand side of the equation. And then we've just got to go and plug it in our calculator to get an answer. So when we plug it in on the calculator, it's going to be 16 squared plus 18 squared minus 2 times 16 times 18 times cos of 32 degrees. And that gives us 9,57 units or centimeters. Remember, we always round off to two decimal places. So 9,57 centimeters. Don't forget your units and make sure that there you've got your two decimal places. So that's an application of how we go about using the cos rule. Most importantly from this example, what I need you to be taking away is what did I write on the left-hand side and what did I write on the right-hand side? How did I choose the information which went on either of those sides? Because technically speaking in an exam, we're not going to write that formula out as a squared is equal to b squared plus c squared. Rather, we're going to write it out substituting in the information immediately. So you can almost think of the cosine rule like this in words to make it a little bit easier for yourself. And that is that the value that we're looking for, so basically the value that we want, all squared, is going to equal side 1 all squared plus side 2 all squared minus 2 times side 1 times side 2 times cos of the included angle. And that's basically how the cosine rule works, where side 1 and side 2, those correspond to the sides that are next to the angle that's included. Let's go then have a look at an example whereby we need to figure out the size of an angle rather than the size of a side when using the cos. So in this example now, we're going to use the cos rule, but we're going to be finding an angle instead of side. But the trick in this question comes in because it says determine the size of the largest angle. Now, the way that you can find the largest angle, and you'll need to make a note of this for yourself, is that the largest angle is always opposite the longest side. So the largest angle is opposite the longest side. So looking at this triangle over here, it's clear to see that the side KM that I've highlighted in yellow, which is 9 centimeters long, is the longest side. And the angle opposite that would be angle L. So that tells us already that angle L is the largest angle. And that's what we're going to be looking to solve for in this triangle. So as I said before, in an exam, it's not going to be explicit that you have to use the cos rule here. So you would need to look at this question first and ask yourself, what conditions or what information is given to me? Well, I'm given the length of all three sides in this triangle. And that corresponds to the second condition of the cos rule. So we know that in this question, we're going to be using the cos rule. And as I said to you before, you can either memorize the way to write it where we've got cos is equal to, so in other words, that second form where we're solving for the angle, or you can go and substitute it into the normal cosine rule formula and then use algebra to help you out. So, in this particular example, we need to find cos of L. That's what we're looking for. So, cos of the angle L is going to be equal to, and if you remember back to the original formula, you'll see that it's got B and C over there, which is basically corresponding to the sides next to the included angle. And then, of course, A is going to correspond to the side that is opposite that included angle. And then obviously B and C at the bottom corresponds to the same bit over there. So when we go and write this out for L, we can clearly see that it's going to be B squared plus C squared, or the two sides that are next to L, which would be LM and KL. So it's going to be LM squared plus KL squared minus the side that is opposite angle L, which is this side, KM. So minus KM squared over 2 times the sides that are next to that angle again. So it's going to be KL times LM. And we can just go and do a bit of substitution, which would mean we're going to have 6 squared plus 5 squared minus 9 squared all over 2 times 6 times 5. And remember, so far we're looking for cos of L. And so if we just want to find L on its own, we would have to use the inverse operation. So in other words, if I wrote L is equal to, when I typed it in on the calculator, it would need to be shift cos of that whole expression there. So in other words, 6 squared plus 5 squared minus 9 squared over 2 times 6 times 5. And when we do that, we get L is equal to 109,47 degrees. So 109,47 degrees. Just a reminder, guys, always use that inverse function when you're trying to find the size of an angle. The third and final rule that we're going to deal with is the area rule. Now just remember that if you're given a normal right angle triangle in a test or exam, you can use the formula that you've been doing since grade 7, which is a half base times the perpendicular height. Whereas when we're given a triangle, like in the diagram below, triangle A, B, C, where we don't have a right angle, well then we're going to try and use this area rule. And the way that you're going to do that is by starting off and choosing an included angle. So choose any of these angles. I'm going to choose angle A, and that would mean that the two sides that are next to that included angle would be side C and side B, with side A opposite. And the way that you then write out this formula is you would say that the area is equal to the two sides that are next to that included angle. So in other words, side C and side B. So it would be a half times side B times side C times sine of the included angle, which is angle A. So basically, just so that you guys are on the same page as me, when dealing with the area rule, it's going to be a half multiplied by the sides that are next to the included angle, and then it's multiplied by sine of that included angle. And so basically we can think of it that the conditions to use the area rule are, firstly, you're given two sides and an included angle, so exactly the same as the cos rule. And secondly, if the question gives you the area of the triangle. So in other words, I say to you, this triangle has an area of 5 centimeters squared, you know that you're going to have to use the area rule. So let's then take a look at a quick example on how to apply this rule. So in this triangle, it says determine the area of triangle ABC. So they need the area of the triangle. We know then that we've got to go ahead and use the area rule. But to use the area rule, we've got to have two sides and an included angle. So do you see here that we've got two sides that are given to us, but we don't have the included angle there at B. And so that means before we can start, we've got to get B, because we can't answer the question without those conditions being fulfilled. Now it's easy enough in this question because we've been given two other angles, so we can just use angles of a triangle to get angle B over there. So let's do that quickly. We've got 180 for angles of a triangle, minus 50, minus 78, which gives us 52 degrees. So angle B over there is 52 degrees. Make sure that you write it out with the reason, angles of triangle ABC. And you can add on that angles of a triangle are supplementary, or whatever you want to do, as long as you write the correct geometric reason next to it. And now that we've done that, we can use our area rule. So that says that the area is going to be equal to a half multiplied by the two sides that are next to that included angle. So the two sides next to the included angle are side BC, which is 36, and side AB, which is 43. So we can write it as a half times AB times BC. Make sure that you know that those two sides are next to that included angle, times by sine of the included angle, which is angle B. So that angle B there is our included angle. And then we can do our substitution. So it's a half times 43 times 36 times sine of 52 degrees. And let's plug that in the calculator. So it's a half times by 43 times 36 times sine of 52. And that gives us 609,92. 609,92. The units are given to us in centimeters, so that means the area will be in centimeters squared. Because for an area, the units are always squared for area.